Okay, so we have reached the level 4 with literal equations, and these are just more challenging literal equations. So with number one is no different. We're solving for x still. Number 1 is no different than an equation like this. 5x plus 2x is equal to 7. Well, what we would do in an equation like this is that since the 5x and the 2x have an x in common, those are like terms which we would combine and make it into a 7x is equal to a 7. However, I'm going to show you a different way that we can do that. A 5x plus a 2x can also be written as a 5 plus a 2x is equal to 7. Because a 5 plus a 2 is a 7x. And so a 5 plus a 2 times an x is the same thing as a 7x. So these mean the same thing, but there is a reason why I wrote it like that. Because we are actually going to do that for the mx plus the nx. These are like terms because they both have an x in their term. So what I can do is I can combine the coefficients, an m plus an n x is equal to p. So what we would do in this equation here is we would actually do a 7x is equal to a 7, and then we would divide by 7 on both sides. So same thing here, this m plus n is technically the coefficient of x, and it's being multiplied by x. So we're going to divide by the coefficient of x, which is m plus n on both sides. So I wind up with x is equal to a p over an m plus n. Now something I want to point out to you guys, you cannot write your answer as x is equal to a p over an m plus a p over an n. That's not acceptable. When you have multiple terms in the denominator, you cannot split it up into two fractions. But if you did have x is equal to an m plus n over p, if you have multiple terms in your numerator, you can split it up into two fractions. So I wanted to make sure that I clarified that, that if you have multiple terms in the denominator, you cannot split it up into two fractions, but multiple terms in the numerator, you can split your answer up. So you absolutely must leave your answer as a p divided by an m plus an n. And that's no different from what we just did in the 5x plus 2x equals 7. It's the same exact process here. So looking at number 2, we want to solve for x again. So on this x plus y in my numerator, I do need to take care of that last because technically there's imaginary parentheses around that. So I'm first going to multiply by the denominator of my fraction on both sides, which is a kx. So I really have, now I have a k times an x times a u is equal to the kx divided by kx goes away, and I'm left with an x plus a y. Now, we have an x on the left and an x on the right. We cannot just isolate the x on the right by subtracting y and say, okay, now x is isolated. No, we need to get the x on one side. This is very similar to if I had something like a 9x is equal to an x plus a 4. What I would do is I would need to get the x on one side of my equation by subtracting this x over. So same thing here, I'm going to subtract this x over. When I subtract that x over, I have a kxy minus an x is equal to a y. And I'm going to rewrite the kxy a little bit differently. I'm actually going to write it as a kyx. There's a reason for that. I'll tell you why in a moment. It's just easier to note that these are like terms. My coefficient of that minus x is just a minus 1. So again, this is very similar to what we did in number 1 here. These are like terms with my x. So what I do is I combine my coefficients into a ky minus a 1 times an x is equal to a y. Same thing that I would do here, I would do a 9 minus a 1, which is an 8, and then I just write 1x is equal to a 4. All right, So same exact thing, I combine my coefficients and I just have one x written on the end, just like over here, and then is equal to a y. And then in this yellow equation, what I would do is I divide by the coefficient to get x by itself. So same thing here, I'm going to divide by my coefficient of x, which is actually a ky minus a 1. And so I have an x is equal to a y over a ky minus a 1. Remember, we cannot simplify this if you have multiple terms in the denominator. You can't split it apart into two separate fractions. You just need to leave it like that. I'm going to erase all this now, but it's no different than solving a normal equation. You just need to connect it to normal equations. All right, number 3. Okay, so technically there's parentheses or imaginary parentheses around this x plus a, so we'll take care of that last. So I'm first going to take care of that times h by dividing by h on both sides. So I have now an x plus an a over a 2, which again, technically imaginary parentheses around that x plus a, is equal to a t over an h. So now I'm going to take care of that divided by 2 by multiplying by 2 on both sides. Here's the most common mistake that I see. A lot of times students do this. All right, we have an x plus an a, and then I have a 2t over a 2h. No, we do not multiply the 2 by the t and the h. Technically, multiplying by 2 is the same thing as multiplying by 2 over 1. So we multiply the 2 times the t. We do not multiply the 2 times the h. The h is just h times 1, which is just an 8. So please don't make that mistake. That is a very common mistake that I see year after year. So I'm solving for x now. I'm going to just subtract a from both sides. And I wind up with x is equal to a 2t over an h minus an a. All right, moving on to number 4. I have a numerator and a denominator here. To get rid of this fraction, I'm going to need to multiply both sides by that denominator, which is a 2x plus 3. When I multiply, since there's multiple terms, I'm multiplying by a 2x plus 3. I'm multiplying by multiple terms. I need to multiply the 4 by the 2x and the 3. So I'm going to put the 2x plus 3 in parentheses, so I know that I need to distribute that 4 in. So I have an 8x plus a 12 is equal to, and a 2x plus a 3 divided by a 2x plus a 3 cancels, and I'm left with a y plus 2x. Now, we have x's on both sides. We can't just isolate one x. We need to get the x to one side. So I'm going to subtract this 2x over. So I have a 6x plus a 12 is equal to a y. And now I'm going to solve for x from here by first subtracting 12 from both sides. And I have a 6x is equal to a y minus a 12. And then I divide by 6 on both sides. And now since there's just multiple terms in my numerator, I can simplify this and I can separate this out into two fractions, which I'm going to, because I can simplify this. A y over a 6 is the same thing as a 1/6y. And you should notice now that a 12 divided by a 6 is a 2. So that's where I actually simplified that 12 over 6. This is the most specific or most simplified answer. I do not want you to leave your answer as an x is equal to a y minus 12 over 6, because that's not fully simplified, and we do want to simplify our answers. All right, that is the end of our lesson. Just a little bit more challenging problems with literal equations.